So today we're going to be discussing proving congruence with two new postulates. We have angle side angle and angle angle side. We're going to start out with angle side angle. So this one says if we have two angles and the included side, remember included means it's between, so it would be between the two angles this time. So the included side of a triangle are congruent to two angles in the included side of another triangle, then those triangles are congruent. So if we look at our example down here, we have angle T is congruent to angle G. Then we have angle R is congruent to angle C. And then the side between those two angles is TR, and that is congruent to our included side on the other triangle, which is GC. So then we can say triangle RTW is congruent to triangle CGH. Okay, let's try a proof with this new postulate. So we have our picture down here, and we're given that segment CP bisects angle BCR, so this angle here, and angle BPR. BPR is down here, so it's bisecting this angle here. So we start out with our given. We have CP bisects angle BCR and angle BPR. That was our given. So then what does bisect mean? Bisect means it cuts it in half, so we're going to use our definition of angle bisector. Okay, so then that tells us this angle is congruent to this one. So I'm going to mark those, and then I'm going to name those. That's BCP, so angle BCP is congruent to angle, this side is RCP, and then we also know the bottom ones are bisected as well, so we have BPC, which is right here, so angle BPC is congruent to RPC, angle RPC. Okay, and I'll go ahead and mark that over here as well. So we have those done. So we have angle and angle, so we need a side. Our included side would be this one right here. So we're looking at CP is congruent to CP, and that is reflexive. So then I'll mark that as being congruent. So then the last piece that we have here is just to say that those triangles are congruent to each other. Let me scoot down just a little bit here. So then we can say triangle BCP is congruent to triangle RCP, and we can say that they are congruent because of angle, side, angle. So ASA. Alright, great. Let's look at another postulate. So our second one today is angle, angle, side. So this one is nice because it goes right along with our other one. So this time if we have two angles and a non-included side of a triangle that are congruent to the corresponding two angles and side of on a second triangle, then those two triangles are congruent. So the big thing here is that it needs to be the corresponding side since it's non-included. So if I look at my example, I have angle K is congruent to angle A. I have angle L is congruent to angle B. Now the included side would be AB and KL, so it can't be that one. It can be any of the other two. Either of the other two. So for this one I'm using J. J is attached to angle K. So I need the one that's attached to angle A, which is AC. And that's the one we have here, so then we can say yes, these two triangles are congruent because of angle, angle, side. So we have triangle JKL is congruent to triangle CAB. Alright, so let's try a proof with this one. So here's our two triangles. We have RTS, we have PMJ. So our given information, we know that angle M is congruent to angle S, so I'm going to mark that on here. Angle M is congruent to angle S. Mark that on my triangle. We also know that angle J is congruent to angle R. So J is over here, and that's congruent to angle R. And then we know that MP is congruent to segment ST. So MP is here, and ST is on this side. And that was our given. Okay, so we're going to try to prove that those two triangles are congruent to each other. So for this one, let's see here, we have here, attached there. So it looks to me like this one, we can do a couple different things here. I can see that angle T is going to be congruent to angle P. And that's our third angle theorem. And you should remember that one from when we were talking about if you know two angles of a triangle are congruent, then the third angle also has to be congruent. We also dealt with that one when we were trying to figure out the sum of the interior angles. We dealt with this third angle theorem. If you know two, then you can find the third. Okay, so then from here, I'm looking at these, and I definitely have my two angles and my non-included sides, so I'm going to say angle JMP is congruent to triangle RST, and I can say angle, angle, side. I could also have said here angle, side, angle. Okay, so either of those would work for this one. Okay. Alright, so let's try another one. So here, we're looking at angle EAD. That's this angle right over here. I'm looking at the given. Is congruent to angle EBC. So EBC, that's this angle right up here. So I'm going to go ahead and write that down. I have angle EAD is congruent to angle EBC. And that's given. Okay, what else is given to us? We also know that AD, so this segment, is congruent to BC. And we're looking at the whole segment, not just this little piece. That's why there's no letter here. AD is congruent to BC. Okay, so those are given to us. So we're trying to prove some congruence here. Now remember, we can do included or non-included sides. So we could do this angle with this angle, or we can deal with this angle. Well, when I'm looking at this triangle, it's a lot easier for me to prove that angle E is congruent to angle E, because we can use a specific property there. Angle E is congruent to angle E. And if you remember, back to our properties, saying that those are equal to each other, that is our reflexive, since they are the same thing. So now if I look at this, I have angle, angle, side. So I can say triangle AED is congruent to triangle, let's see, it would be BEC, and that is because of angle, angle, side. But if you notice, that's not what they're asking for. They're asking for AE and BE. Okay? But now that we have proven these triangles to be congruent, then we can say, well then AE, this first piece, sorry, let me scoot that up just a little bit. We can say segment AE, which is this first piece of my triangle, is congruent to segment BE. And we can say that those are congruent because congruent parts of congruent triangles are congruent. If you remember those 5 letters, we did those a week and a half ago, I believe. So congruent parts of congruent triangles are congruent. Since we proved the triangle's congruent, then we know the segments all have to be congruent. Okay? Alright, that is the last one for today. So we had 2 new postulates and then we did 3 proofs. So make sure that you have all of those written down. Also on your WSQ, make sure you're giving me at least 5 good sentences to get full credit for that. And I'll see you in class tomorrow.